Wireless things. Buildingwarden.com. Network routing and communication. What is required? To collect and transfer the sensor data with the most cost-effective infrastructure, the lower possible number of nodes. To maximize battery longevity. To make sure that there is no data lost due to any possible communication problems. The EW is designed on a distributed architecture concept. This includes the network nodes, each representing a physical location where data are collected and transmitted to the gateway. Thus, a node is a collection of closely located low-power sensors and a wireless moat. The EW hardware allows up to 4 sensors to all be scanned and transmitted via the same wireless moat. The gateway, which manages all the wireless network data and connects to the internet in order to save them. The gateway is also used to dispatch configuration data to the network nodes. Both the nodes and the gateway are equipped with a microcontroller that can run 802.15.4 programs. Such programs are needed in order to manage the sensor data. However, as we will see below, programs here may also be used for carrying out specific control actions. The network data saved in the EW database are managed by a special web application. This web application also serves as an advanced visual interface of the network. It is called the EW dashboard, or simply the dashboard.
The WSN team, nodes and gateway.
2 types of power supply.
1. Battery. 2. Mains.
2 types of status.
1. Active. 2. Sleeping.
About relaying.
Relay nodes are always EW modules that never sleep. Energy meters, as battery independent, are typically candidates for assuming a relaying role in the routing protocol. These modules do not need any battery and do not have any respective energy limitations. Instead of programming them to be by default in sleep mode, they can be at no performance cost on the alert, so we can use them as relay nodes. They offer a good, energy-wise pathway for data transmission, for nodes not directly reaching the gateway. Very often, making use of such nodes and assigning them this special relaying role will solve the effective distance problem of the remote modules.
An energy meter is most suitable to act as a relay node. Basic communication concepts.
The gateway. All new nodes entering the network need to identify a parent. First node enters the network via gateway. Here, gateway is the parent and node 1 is the child. Nodes not sampling or transmitting data are, by default, sleeping. In this way, battery longevity is secured. When time to sample has come, the node wakes up. In principle, before a transmission of a sample, the node always checks if there is a parent defined. Nodes when first turned on start without a parent defined. Let's see what happens if there is no parent defined for node A. Node A broadcasts a request for parent package to the network, and waits 1 second for responses. Request for parent is received. When a request for parent is sent, all nodes respond, provided only they have a defined parent. This node cannot answer to request for parent. The process will repeat till node A is heard by a node that has set its parent. Request for parent is received. This node has a defined parent and can respond to the request. This node sends back a request for parent response with a random delay 0 and 500 milliseconds. This node will be added to the candidate list. The list includes node ID and RSSI value for every candidate parent. The best candidate is chosen as parent, by means of the best RSSI. In telecommunications, received signal strength indicator, RSSI, is a measurement of the power present in a received radio signal. The receiving node checks its child list and eliminates all parent candidate nodes that are already established as its childs. Avoiding loops. Because a node always checks its child list, it will never accept as a parent a node included in its child list. This is a necessary provision in order to avoid communication loops. After 1 second expires, node A sets parent ID as the chosen candidate ID. Now, node A is able to transmit samples to its parent. The node sends to its parents its sample along the pair, child ID, parent ID. Every node has a child list, child ID, parent ID. In this way, any node can find the path to send a packet. In order to empower this, every node sends its pair to its parent along the sample. So, the node sends to its parents its sample along the pair, child ID, parent ID, and waits for an acknowledgement signal. The acknowledgement signal is received, and the node goes happily back to sleep until next sampling.
Alas, this is not always the case. Let's see what may go wrong.
The node sends to its parents its sample along the pair, child ID, parent ID, and waits for an acknowledgement signal. Unfortunately, the acknowledgement signal is not received. There are many possible causes of such a communication loss: transmission distance, flat battery, etc. The node buffers its data. Before the next transmission of samples, buffered and new, the node will search for a new parent. Our node has a significant memory and can buffer a huge amount of data, all its samples of 1-2 days. This is enough time to fix the cause of the communication loss without data loss.
Let's see an example of network topology.
The child node 7 sends to its parent node 3 its sample along the pair, 7,3. This pair is stored on node 3 child list. Node 3 will also store in its child list the pair, 4,3. At the moment child node 4 sends it along its sample. Node 3 sends to its parent node 5 its sample along with the pair, 5,3, and its child list, 7,3, 4,3. This table allows essentially the gateway to reach any node it wishes. In this way, any node is able to reach, in an ad hoc way, any other node.
What may happen after parent-child relationship ceases to exist?
An ended parent-child relationship will trigger a new parent identification routine, and may result to a new child list structure. In this case, it is necessary to update the child list, so that nodes are aware of the changes. When a child-parent pair is updated, this update will be broadcasted through the tree. The gateway will receive the update, and will realize the change as its child list has changed. Important note: this process applies to changes in the child-parent relationship and not when a new child pair is introduced. The gateway will take no action in cases of new nodes. Its child list will be automatically updated through the tree, but there is no need to send the change down the network paths. It has been automatically done.
Thank you for watching.